Interpretation of Surah Ya Sin, verses 37 to 40 as a definition of the beginning of a lunar calendar.
Scientists define this rotational direction as moving from west to east. In the following verse, Yasin 38, Allah further elaborates on an astronomical phenomenon linked to Earth's motion. The sun travels for its fixed term. That is the design of the Almighty, all-knowing. Thus, contrary to traditional literal interpretations, the phrase "the sun runs" in this verse refers to the apparent motion of the sun as it seems to move from east to west in the sky. This is akin to the experience of driving, where trees and other objects appear to move in the opposite direction of our vehicle's movement. However, this apparent movement from east to west applies to all celestial bodies, including stars, other planets in our solar system, and the moon. Since the Earth completes a full rotation of 360 degrees on its axis in 24 hours, physics allows us to calculate the Earth's angular velocity as 360 degrees divided by 24 hours, which equals about 15 degrees per hour. Accordingly, celestial objects like the sun and the moon also appear to move at this apparent angular speed of 15 degrees per hour. However, as a satellite of Earth, the moon physically orbits the Earth. The synodic orbit of the moon, which completes a full 360-degree circle in approximately 29.5 days, results in an orbital angular velocity of 360 degrees divided by 29.5 days, approximately 0.5 degrees per hour. Thus, if the apparent angular speed of the sun remains at 15 degrees per hour, the apparent motion of the moon is slightly slower, at about 14.5 degrees per hour obtained from 15 degrees minus 0.5. This difference in the angular velocities of the sun and the moon causes, at certain positions, the sun and the moon to appear as if they are chasing each other across the sky. Before conjunction, the elongation, i.e., the angle between the sun and the moon is seen from Earth gets smaller, making it appear as though the sun is chasing the moon. Visually, we can observe this from the Earth's surface, where the moon's phase continues to wane and become smaller as it approaches conjunction. That is waning crescent. Conversely, after conjunction, the elongation increases because the sun has moved away from the moon. From the Earth's perspective, we see the moon's phase grow larger, and it is waxing crescent. This slide presents a simplified illustration featuring a cyclist, a pedestrian, and a tree. Since the cyclist moves at a speed of 20 kilometers per hour while the pedestrian walks at 5 kilometers per hour, the distance between them gradually decreases until they align in a straight line with the tree. This alignment, where the cyclist, pedestrian, and tree form a single line, illustrates the concept of conjunction, a moment in which the distance between the cyclist and the pedestrian becomes zero. However, since both maintain constant speeds, the distance between them immediately begins to increase again even just 1 second after the conjunction occurs. Remarkably, Allah explains the phenomenon of changing elongation, how we perceive it from Earth's surface, and the chasing process between the sun and the moon very accurately yet simply in Surah Ya Sin verse 39. As for the moon, we have ordained precise phases for it, until it ends up looking like an old, curved palm stalk. At this final stage, Allah refers again to the following verse, Yasin verse 40. It is impossible for the sun to overtake the moon, nor can the night precede the day, and each one moves in its orbit. These verses describe extraordinary natural facts. First, mathematically, they define conjunction as the 0 point. In mathematics, this 0 point has no dimension, meaning, even 1 second after the 0 point or conjunction, the moon has entered its first stage and the crescent has formed, regardless of whether we can see it or not. Second, although the sun can overtake the moon at conjunction, this event will not cause a collision because they are separated by vastly different scales of space. The sun is about 150 million kilometers away from Earth, while the moon is only approximately 400,000 kilometers away. As elongation decreases, the moon's crescent shrinks, leading toward conjunction, the point where elongation is minimal and transitions from the last phase to the first new phase. Afterward, elongation increases again, causing the crescent to grow larger. Meanwhile, on day 7, the moon was below. On day 14, at the far left of its orbit. On day 21, at the top of its orbit. Therefore, on day 24, the moon is in a position where correspondingly, the waning crescent is visible, as shown in the inset image. Note also there are two observers on Earth positioned diametrically opposite. One is green and the other orange. When the green observer faces away from the sun, night side, the orange one is facing the sun, day side. Visibility issues. The waning crescent can appear large but be invisible if the observer is on the night side or it is below the horizon. Remember that the sun and moon are on the opposite side. Even during the day, if the sun's brightness is so intense, the crescent remains unseen. From day 25 to the 28th, the waning crescent gets smaller as elongation diminishes. On day 29, conjunction occurs when the sun catches up with the moon, making elongation and the moon's phase at their minimum. However, due to constant apparent speeds, 15 degrees per hour for sun and 14.5 degrees per hour for the moon, the crescent must have already formed even 1 second after conjunction, even if it is not visible from Earth. Visibility of the crescent. In the first few days, days 1 to 5, the crescent grows larger. However, the same visibility rules apply. If observers are on the night side or in strong sunlight, the crescent might remain unseen. The best chance to see the waxing crescent is at sunset when the sunlight weakens. It concludes that the absence of visibility does not mean the crescent is not there. Even crescent on day 5, it is invisible when it is below the horizon or when the sun's intensity overwhelms it. At sunset in Jakarta on the 29th day of the lunar calendar, we assume that the crescent is too thin and its altitude is extremely low, making it invisible to the green figure in the video. Meanwhile, at that moment, somewhere in Africa or Europe, GMT-1, it is about 8 a.m., represented by the orange figure in the video. By the next day at 4 a.m. Jakarta time, 10 hours after sunset, the elongation increases at a rate of approximately 0.5 degrees per hour. Thus, after 10 hours, the elongation is about 5 degrees greater than it was at sunset in Jakarta. Since elongation strongly correlates with the size of the crescent must also be significantly larger than it was at sunset. It is important to note that this corresponds to sunset for the orange figure in Africa or Europe, GMT-1. At around 4 a.m. Jakarta time, the moon is approximately 30 degrees below the eastern horizon, as represented by the green figure, making it impossible to see. However, it is important to note that at this very moment, the orange figure in Africa or Europe, GMT-1, which is geographically farther west, can observe a large crescent because it is sunset there. This leads to an interesting contradiction. While the green figure in Jakarta, GMT+7, cannot recognize the crescent due to its position below the horizon, the orange figure in the west, GMT-1, must acknowledge the same illuminated portion of the moon as a crescent. By 8 a.m. in Jakarta, GMT+7, the crescent has grown larger, having elapsed approximately 14 hours since sunset. Due to the overwhelming brightness of sunlight, people in Jakarta cannot see this crescent. However, farther west in the Americas, GMT-7, the same crescent becomes visible as the intensity of sunlight diminishes at sunset. This discrepancy presents a major challenge. Muslims in the Americas must acknowledge this prominent crescent, yet some Muslim scholars strictly forbid Muslims in Jakarta from recognizing the same object as a crescent. This delicate situation further complicates the Muslim calendrical system, as it results in Muslims in Jakarta beginning Ramadan a day later than their counterparts in the Americas. The issue becomes even more complex because Muslims in the West commence all their acts of worship nearly 12 hours ahead of those in the East. Under normal circumstances, this pattern should be reversed, with Muslims in the East performing ibadah approximately 12 hours before those in the West. Therefore, it can be concluded that the moon's altitude is not a reliable measure of the crescent's size. Muslims cannot establish a dependable Islamic calendar if it is based solely on local sighting. Thus, the development of a global Hijri calendar is essential, one that considers the crescent's presence globally rather than relying on local visibility.